For this demo, I'm using Visual Studio Code. In my IDE, you see I have a CloudFormation template called lambda-cron.yaml. A CloudFormation template is a JSON or YAML formatted text file. Think of them as blueprints for building your AWS resources. Let us look at the section starting with resources. Everything you need as part of your project is a resource, like your servers, load balancers, even network firewall rules if you decide to implement them as IAC. I have defined multiple resources here, including a Lambda function, the permissions attached to this function, and a schedule to trigger this Lambda. Notice how the function code is part of the same template. You can choose to keep it separate, but for now, I have included it in the template. You will also notice that I am tagging my Lambda. This makes them easily identifiable, and you can also use tags to group resources like everything belonging to a same environment or cost center. The other section I want to highlight here is parameters. You can use parameters to ingest dynamic values into your template. Like in this case, I'm using a preset schedule with a default value of 1 minute if nothing else is specified. Another section I want to highlight here is output section. Here, you can capture and output information about resources created in this stack. Let's use our Lambda function template to create a stack using command line. Let's call it CFN Lambda stack. We will also allow CloudFormation to create IAM resources on our behalf. Remember, we talked about stacks. With CloudFormation, you manage related resources as a single unit called a stack. You create, update, and delete a collection of resources by creating, updating, and deleting stacks. All the resources in a stack are defined by the stack's CloudFormation template. While the stack is deploying, let's switch to CloudFormation console and have a look at the stack there. Here for each stack, you can see the stack info, different resources being created, outputs, and a lot of other information about the particular stack. Let's wait for the stack to be created. Now the stack is in create complete mode. Let's look at the resources created by this stack. We will start with Lambda function and see the code. Notice how we are logging information from within the function itself. Let's also validate the schedule rule is created and it is set to run every minute and make sure the target is correct. Last, let's look at the Lambda function logs to see that it is being triggered and we see the information printed in the logs. Everything looks okay for this function. Let us deploy a similar function using AWS CDK. We are back in the VS Code. Now you see that I have a file called app.py. I'm using Python now to implement not only my function but also the IAC. See how I am extending stack class and adding custom properties. I created a class called lambda-cron stack and I'm creating similar resources in the stack. A function and a rule to trigger this function. See how I have kept the application code separated here in a file called lambda-handler.py. The code is similar to what we had for other Lambda. An advantage of using CDK is that you can write unit tests to test your infrastructure in the same way as you would write for your application. Let's run the test here and see if everything is as planned. You see, there is an error message because I have changed the schedule. Let's fix it back and run our test again. Remember we talked about CDK being a generator. Let's see how CDK converts this code to CloudFormation. The purpose of showing you this file is while abstraction is helpful, it's important to know the underlying details. Here you see all the resources represented as CloudFormation YAML generated by CDK. Let's deploy the CDK stack. While the stack is deploying, let's switch to CloudFormation console and have a look at the stack there. You will notice that from this point onwards, there is not much difference here as compared to how we deploy using CloudFormation. Here for each stack, you can see the stack info, different resources being created, outputs, and a lot of other information about the particular stack. Let's wait for the stack to be created. Now the stack is in create complete mode. Let's look at the resources created by this stack. We'll start with Lambda function and see the code. Notice how we are logging information in similar way within the function itself. Let's also validate the scheduled rule is created. Notice how it is set to run at 6 p.m. every weekday to invoke our newly created Lambda. Last, let's look at the Lambda function logs to see that it is being triggered and we see the information printed in the logs. No logs. This is expected because the schedule is not set to every minute, but it will trigger at 6 p.m. on weekdays. However, given the configuration looks okay, we can trust this Lambda function to be invoked.